Hello everybody. Today we will build a staircase using a very simple geometry node setup. Now we have our default cube. Let's delete the cube and let's add a plane instead. Let's go to geometry node and let's expand the left section so that we have some more space. Let's click on new and we have the group input and the group output. Now the first thing that we want is a grid, and let's plug our grid with our output, and there is not much change because grids and planes are actually the same. Grids have some more points, that's all. So if I go to wireframe, this is how our grid looks like, and this is our plane. So we can increase the vertices from 3 to let's say 50, and we will get a dense grid. And we also want to increase the size. So let's give the size as 10 meters. And what we want is a large staircase, and I think 350 is too much. What I want is 50. Yeah. So this is what we want, and let's go to our default viewport. And so what we want is basically we have so many lines. So we want to basically give them a thickness linearly. And to do that, we'll use another node called extrude mesh. We already know what this does. So this will give a thickness of something like a 1 meter, like the offset is 1 to our mesh. Um, but this thickness it is giving everywhere. What we want is it should change edge by edge, not edge by edge, like line by line. So what we can do is we can just drag the offset, and here let's give a random value. And we know what this does. So I think we have done this before. This will create something like a city because every every point will get a random value between 0 and 1. And so we will have a building like structure, like a lot of buildings. So what we want instead is depending on the position, the values they get should be linear, and then it will be like a staircase, and that is also very easy. We have a gradient texture, and here let's plug the factor with our offset scale. And now we have something like a staircase. So if I zoom in, this looks very much like a stair. There is one problem although. When the stair is going down, um, there are lots of boxy holes. And that is because the z value is negative. And since all of these are our points, um, this kind of effect is coming. This will also come for the top if we look from the bottom. But because this is the top, we may ignore what is there below. But we definitely cannot ignore this part. So fixing this is actually very easy. What we can simply do is we can simply translate this bottom portion to the top. But before doing that, let me just give you a brief idea of how these nodes are working. So we'll go to viewer, and what we will do is we will plug our mesh with our geometry in the viewer, and we will plug the factor with the value, and we have something like a black and white effect. So what this does is so basically this lowest point, this one is our 0, and from 0 it is going towards 1, and that is basically what is happening here. And this is for our linear. So instead of a linear we can also do a quadratic, and we can see what is happening now. We have our staircase, but this is too steep. This doesn't look like a stair, something it looks something like a mountain. And this is the quadratic distribution of how the points should behave. If I simply close our viewer and if I take a look at the mesh, this is what will happen. So this is how the displacements will come. If I use an easing, it will become very, very smaller. So there are still some displacements here, but this will be very small, and it will kind of look like few stairs. And then there is a diagonal. So all of these things will be happening diagonally. So like the topmost point diagonally, this will be the highest, and so the bottommost point will be the lowest, something like this. And as you can see, all of these like points, each of these points have like different kind of AZ value. Now next comes our spherical. Now this is very interesting. This will look something like a pyramid. So this point, the middlemost point is at the top. The remaining points are displaced depending on their position. Then comes a quadratic sphere. This will also look like a pyramid, uh, like using the quadratic distribution. And lastly, we have a radial. So radial is also very interesting. If I just open the viewer, so basically it will start from 0 here, and it will work with something like a radius. So it will go in this direction to 1. So 0 here and 1 here, something like this. So that is how it is working. Now the problem that we have is the bottom part, and we can fix it using a math note. So we will do a math, and let's add a value. So mm, our dimension is 10 and 10. So 5 is below and 5 is at the top. So if I just add a value of 5, it should resolve it. And let's close the viewer. I think it's not required for now. So we have a beautiful staircase. Now you may think that the staircase is too steep. So when we have stairs, we generally don't have it so steep. So you can see uh, it is kind of difficult to climb this one. So what we can do is we can make it a little bit smoother. Smoother in the sense the height should be a little bit less. And to do that, we will add another math node. And here, instead of an add, we will do a multiply, and this will be very smooth now. So what we are doing is basically for every offset, we are multiplying it with a 0.5. I don't know if 0.5 is a good value, but if we make it less, it will become something like this. Very, very smooth. And if I make it high, it will become something like this. So we had a 1. So I think we can do a 0.6. Yeah, something like this. This looks like a good staircase. So that is how you can procedurally create a staircase. And using different techniques, we can also create radial staircases or other kinds of staircases that you may want to use in your game or your project. So we will see more of this coming forward. So that's it for this video, folks, and we'll see you soon with another very interesting video. So see ya.